Hey, welcome to this explainer. You know, we're surrounded by software. It's the invisible force that powers literally everything in our lives, our phones, our cars, our homes. But what happens when that invisible force just breaks? Well, we're about to find out.
So, picture this. It's July 2022. Millions of people wake up and suddenly their phones are basically just bricks. The internet is down, you can't even call emergency services. I mean, we've all had that mini heart attack when a single app on our phone freezes, right? But imagine that feeling, scaled up to an entire nation. This wasn't just some small glitch. This was a massive, system-wide failure.
So, the huge question is, how? How does a system that we depend on so completely just fall apart like that? Well, to get to the bottom of it, we're going to have to look under the hood. We're going to go on a little diagnostic journey, and by the end of this, you'll have the exact toolkit to see how it all went down.
And to do that, to really get why it failed, we first need to understand its structure. The best way to think about any computer system is like a pyramid. Every bit of software has its place in a specific layer, and if one of those bottom layers cracks, well, everything built on top of it is in big trouble. So let's start at the very foundation.
Okay, way down at the bottom, we've got something called firmware. This is the really deep stuff. It's a tiny, tiny program that's literally burned right onto a piece of hardware, a chip. It's the very first thing that wakes up when you turn something on. Think of it like the little bit of a brain in your keyboard that tells it how to be a keyboard, or the startup code in your Wi-Fi router. It's super basic, but absolutely essential. Moving up one level from there, we get to the operating system, or OS. This is the big boss, the manager in the middle. We're talking Windows, Mac OS, Android, that kind of thing. The OS is what juggles all the hardware, manages the memory and files, and basically gives all your apps a stable stage to perform on. It's the critical bridge between the raw hardware and the software you actually use.
And then, right at the very top, we have the part we all know and interact with every single day, applications, or, apps. This is everything you click on, everything you launch on purpose. Your web browser like Chrome, creative tools like Photoshop, or the BBC iPlayer you use to stream shows. They all sit right there at the peak of the pyramid.
So, here it is, our complete software pyramid, or what people in the biz call a stack. You've got the physical hardware at the base, which gets its instructions from the firmware, which then supports the operating system, which, finally, runs all our applications. And this visual makes a really important point crystal clear. Every single layer depends completely on the one below it. A crack in that foundation puts the entire thing at risk of collapsing.
But you know what? Understanding that structure, that's only half the story. To really get why software breaks, we also have to look at two huge fundamental choices that get made long before you ever even download an app.
The first choice is all about how it's made. Is it off-the-shelf software like Microsoft Office? A general tool made for millions of people? Or is it bespoke software, something that's custom-built for one very specific job, like a patient tracking system for a hospital? It's kind of like buying a standard hammer at a hardware store versus having a blacksmith forge a special tool just for you. The second choice, and this one is huge, is about ownership. Is the software proprietary? This means the source code, the actual recipe for how it works, is a secret owned by a company. You buy a license to use it, but you can't peek inside. Or is it open source? This is where the recipe is totally public. Anyone can see it, anyone can use it, and anyone can even try to improve it. And this table really breaks down the trade-offs. Open source stuff is usually free, and the license gives you the freedom to copy it, change it, whatever. Proprietary software, on the other hand, costs money, has really restrictive rules, and it makes you completely dependent on that one company for any fixes or updates. That's what people call vendor lock-in. You're stuck in their world.
Okay, so this brings up a really fascinating question. I mean, if you've spent years of your life building a complex piece of software, say something that models how dinosaurs walked, why on earth would you just give it away for free? It doesn't seem to make any sense.
Well, the answer comes straight from the scientist who did it, Bill Sellers. For him, the real value wasn't in selling the software, it was in moving the science forward. By making it open source, tons of other researchers could use it, test his work, and build on his findings. See, in the world of science, that kind of collaboration and transparency is worth way more than money.
So that makes sense for a scientist. But what about the biggest, richest companies in the world? Why would a multi-billion-dollar corporation like Twitter or Google build its entire empire on top of free code that it doesn't even own? What's in it for them?
James Harlow from Twitter puts it perfectly. It's all about control and flexibility.
With open source, if they find a bug or need a new feature, they don't have to file a ticket and wait for some other company to fix it. Nope, they can dive right into the code, fix it themselves, and even share that fix with the rest of the community, making the software better for everyone.
And believe me, open source is not some little niche hobby. It is the backbone of the entire modern internet. Huge platforms like Twitter, the BBC, Shopify, even the very core of Google's Android, the most popular mobile OS in the world, they all run on a foundation of open source software. It's everywhere.
Okay, so let's circle all the way back to that massive outage we started with. We've got our diagnostic toolkit ready now. We understand the software pyramid. We understand the different ways software can be built and owned. We are ready to be tech detectives.
And here is the diagnosis. The problem wasn't an app on your phone. The failure happened way down at the bottom of that pyramid. A software update, most likely some kind of proprietary, bespoke code, went wrong. It gave bad instructions to the core network routers, messing them up at the firmware and OS level. And once that foundation crumbled, all the applications and services on top, they never stood a chance. It was a perfect, catastrophic domino effect.
Knowing what went wrong is one thing, but the real million-dollar question is prevention, right? If you're the one building these critical systems, how do you make sure one single mistake doesn't cause a nationwide blackout?
Well, to stop this, the industry has come up with some key strategies for building tougher systems. First, staged rollouts. You don't push an update to everyone at once. You give it to a small group first to see if anything breaks. Second, redundancy. You have backup systems ready to go, often from totally different companies, so a single failure can't take you down. Third, automated health checks. Computers are constantly monitoring everything and can automatically shut down a failing part before it infects the whole system. And finally, postmortems. After every single failure, you do a deep dive to make sure you learn from it and never make that same mistake twice. So here's the big takeaway from all of this. Whether you're just a frustrated user trying to figure out why your phone is acting weird, or you're an engineer building the next big thing, understanding the software stack and the different software models gives you this incredibly powerful lens. It helps you diagnose what went wrong, and more importantly, it shows all of us how we can build better, more reliable things in the future.
And that leaves me with one final question for you. Imagine you were tasked with building a super important app for your school or maybe a local business. Now that you have this knowledge, what choices would you make? Would you go proprietary or open source? Off the shelf or totally bespoke? There's no single right answer, but thinking about it really shows you the constant balancing act between cost, control, and reliability that shapes all the software around us. Thanks for joining me for this explainer.